All right, this is a big one. Shifting graphs up and down, left and right, and making them steeper or wider, compressing them or contracting them, however you want to think about it. All right, so let's review the easiest parent function. All right, we did a little bit of this yesterday, 2 to the x. I think if you have a firm understanding of a parent function, it becomes easier to do manipulations like doing a plus one here, maybe doing a minus one here, multiplying by 3. When you have an understanding of just this piece, it makes all these little changes a little bit easier. So let's just focus on 2 to the x. Negative 2 leads to 1/4. Negative 1 leads to 1 over 2. 0 leads to 1. 1 leads to 2. 2 leads to 4. I keep going. 3 leads to 8. 4 leads to 16. So having an understanding of this is good because then everything else is a manipulation of this, right? Everything else is going to be, we're going to learn what these do to impact what type of inputs we'll use and how they're associated with the outputs, how the outputs might change, all that type of stuff. Okay, so here it is. This is the general form. We're used to seeing the general form as y equals a times b to the x. So we've dealt with this before. We've dealt with this being sort of like a multiplier. We haven't talked so much about how it makes these things compress or contract. But now we're adding this and this. How I want you to think about this is the h. Look, it's directly next to the x. So the h impacts input, whereas the k comes at the end. K impacts your output. Now, it doesn't affect my input as in like it changes what I'm allowed to input. No, what I'm saying is what used to be 2 squared is 4. If I suddenly change this to 2 to the power of x plus 1, I don't need a 2 anymore to get 4. I only need to do an input of 1 and I'll still get 4. So suddenly, if I'm comparing the charts, the input charts of 2 to the x, in which case an input of 2 gets me 4, versus 2 to the power of x plus 1, I don't actually need to use 2 to get to 4. I can use 1 and get to 4. So what just happened here? Well, what happened is I used to have a point at 2, 4. Now I have a point at 1, 4. So what happened? I moved it to the left. So anytime you see addition here, you think, oh, I'm allowed to use smaller numbers. I can plug in smaller numbers to get the same result, meaning it's going to move to the left. If it's a negative, you go, oh, I need bigger numbers, right? So it's going to move to the right. That's, I think, the toughest one to get. People do a pretty decent job of piecing together that k impacts the output because you're saying if you have 2 to the x and I do 2 to the first, I get 2. When I do 2 to the power of x plus 3, now when I do 2 to the first, I'll get 2 plus 3 is 5. So when suddenly I'm 3 above where I used to be on the parent function. So what does this look like? It looks like, well, we've got graphs like this. And suddenly when I start doing this shift, now it's the same graph, it's just elevated a bit. And notice if it's elevated a bit, what happens to the asymptote? The asymptote changes as well. In fact, this is pretty much always going to be your asymptote, right? Because that's what if you think about this as like, 2 to the power of x plus 3. This, we've talked before about how it'll never be 0. Well, that means that even if I do 2 to the negative 100th plus 3, Well, the 3 means that, no matter how small this is, I'll be at like 3.000000001. Well, it's still bigger than 3. So I still have an invisible line that I can't cross. It's just that now it's not 0. Now it's like 3. It's a different line that I can't cross. Doesn't mean I'm still limited, right? It's a great little example here. We've got our base function 2 to the power of x, or 4 times 2 to the power of x, and now it's been changed. So it's been shifted down. Every point I went down 3. I also took every point and I went, see how this is minus, meaning I got to use bigger numbers. So I need to move to the right. So I moved to the right and down 3. I moved to the right and down 3. It's not to say that you can't still just make a regular old XY chart and say, I'm just going to plug numbers in here and see what happens, right? You can still do 2 to the power of 2 minus 1, or, 4 times. You can still you can still very easily calculate that. I just think it's helpful to have a firm grasp on the like, oh, I know this part, and therefore it's not so bad for me to say, oh, everything's going to be 4 times as big, but then minus 3, and everything's going to be a little bit to the right, right? It's good to have that level of understanding. So this is great. Let's break them down piece by piece. Why are we stretching or compressing? Because if I'm tripling everything, I'm accelerating at a faster rate. So I'm going to go up way faster. If I'm dividing everything by 3, I'm going to be accelerating at a slower rate. Why do we move left or right? Because in this problem, right, if we think about something like, let's identify some crucial points here. 1, 3. Because 3 to the first equals 3. So I plugged in 1, I got 3. This time, we're at 3, 3. So we're at the same output, but what did it take to get the same output? It took a different input. Why? Because it's 3 to the power of x minus 2. So 3 to the power of 3 minus 2 turns into 3 to the first, which is 3. But that's why I had to move to the right. Because in order to get the same output as what's on the red graph, I need to be further over here. And then it's going to be the reverse when we move this way. I'm adding 2. So in order for me to get 3 to the first, I'll just do 3 to the power of negative 1 plus 2. And that also gets me to 3 to the first, which gets 3. So that's a bit of an explanation there on the horizontal shifts. And then here we have shifting up or down. So here in yellow is 2 to the power of x. Here's 2x plus 3. Here's 2x minus 3. All that's happened, it's the same graph, except this one has been moved up, and now the line that it approaches is, instead of almost getting close to 0, I get close to 3. Instead of getting close to 0, I get close to negative 3 for this one. There's a little more explanation. The best thing for us to do is do an example on our own and try and make some predictions. So guys, can you pause and think about what would you predict this graph to be like? What are some things you might be able to predict? So pause here, think about that. And I'll say now, hopefully you hit play again. You should predict things like this graph will compress because we're doubling the values. I also am thinking, this tells me move to the right because I need bigger numbers, right? If you want to get something like 2 to the power of 0, you need to plug in 3. It used to be, for regular old 2 to the x, that if you wanted to plug in 0, you could get 2 to the power of 0. But if I plug in 0, with this one, I'm in some serious heat because I'm going to get 0 minus 3. and then lastly, up 2. Because this is like the last thing that happens. I do all this work and then I add 2. It's like, think about it, you're like tagging it on at the end. So the last thing that happens is it'll be moved up a little bit, it'll be moved right a bit, little bit. So it'll probably look something like this compared to 2 to the x, probably looking more like this. So just be moved up and to the right. Desmos is a great site for, you can just type this stuff in and see how it compares and see the overlay. So please do stuff like this when you're doing homework. Desmos is a great, great tool, and I hope that you use it. I hope this video is helpful. We're going to practice this stuff a ton. It takes some getting used to, but please continue to come back to this video as a refresher.